Hello? Perfect. So, once again, I can't see you. I expect that you can see me and you can hear me, but this is unidirectional data flow. We can improve, I guess. So, if you raise your hand, just some random person, a few of them. Okay, let's say someone from the top left can clap. Okay, that's sound, perfect. Or you can wave your phone screen, that's also perfect. So we have like 2 ways I can interact with you. For the next 45 minutes-ish, we are gonna sit here and you are gonna, unfortunately, wait for my story and listen to my story of refactoring code bases in a very, very as I would say, established pattern nowadays. It's happening a lot this year, and I think it's worth sharing the. Excuse me? People yelling at me. Wow. This is beautiful. So, mandatory presentation slide. I work at Mobimeo. We are in Berlin. We work on mobility. So if you want to fight the private cars and promote public transportation and you like to work on SDKs, please give me a call or well, send me an email or Twitter or whatever. You also can get me in the corridor later. We are hiring, of course, every position, iOS, Android, everything. Let's start. I mean, they send me here, so I have to do it. So in the last 10 years, I have been working on Android projects. Most of them were, they were very diverse from a business point of view, SDKs, end users, apps. But most of them were the result of very specific startup mindset growing process. You need to be fast. You are probably just trying to validate your product idea, and you work, you ship stuff, and after like a while, a few months, I will say, you end up with a product and a project and a code base. They are pretty similar to a lot of other similar startup code bases. Yeah. That's just the way it is. You can't help it actually because you basically cut corners. You want to be on the market before your competitors, so you just you can't help it. You are probably in a startup environment. It's not enough money. You are probably the only developer, and you don't really know what you're doing from a product point of view, and yeah, unfortunately also from a technical point of view, because that's a consequence. And after a few months, you end up with something like this. This is like the proper representation of most of my initial code bases. The monolith, the infamous monolith. You have one gigantic Gradle module. You have pure testing. You have pure testing, I mean like none. Because testing slows down by 30% because there are studies, yes. So you don't have testing. You have duplication because you gotta be fast. I can't actually abstract stuff. I need to copy paste. You don't have dependency injection most of the time. You just throw some static get instance there, singleton all the things, and you're good to go. And you have code smells. But at some point you start growing your team, you are lucky, and your product actually becomes something that can be real. And you made the cut. You get some VC money, and you start putting more people on the project. And this is how the project evolved. So basically, you have a few more developers working with the monolith, and I mean, struggle. You start struggling because you don't have knowledge sharing. You have a lot of communication overhead. You have basically no documentation, so everyone has to talk to everyone else to understand how thing works. The whole idea becomes very, very, very clear how messy and how difficult it is working with the code base when you have more people, you have more Jira cards, and you have more feature to be developed. And what you do, you need some sort of team developing strategy. So in my experience, you basically probably will go for something like feature branches. Everyone branches from develop, they work on their own stuff. And when they come back to develop, well, you have merge conflicts. Constantly merge conflict because in a very messy code base, you have spaghetti code, and probably all of you are working on the same 10 files. Like there is no other way around. Things like the dagger component, I mean, everyone is touching it. Strings, everyone is probably adding some string. And other example could be like the main activity. Everyone is touching it. So we need to simplify. And simplification comes with acknowledging the fact that you have code that is too coupled. Basically, the team cannot be fast enough because they are wasting more time solving merge conflict than actually coding. Even worse, more people, more code, and one single Gradle module, the build gets very slow. There is a problem intrinsically in having the build slow on Android because if you have one single module, well, you can't actually leverage the progress that we did in the last few years. From a hardware point of view, they can't push the speed that high, so they went horizontal. Let's put more cores in our CPUs. And to increase concurrency, actually, a lot of software went in the same direction. And Gradle is a big example of that. So you can parallelize your build, but to do it, you need more modules. Because if you have just one module, well, Gradle will build one module with one core, and the rest of your CPU will just be idle or probably running Slack and Chrome and still being 100% CPU load. But we need to simplify, and we can start simplifying, speeding up the build. Basic stuff can be use the latest Android Gradle plugin or the latest Gradle. Enable caching, always useful. In a debug, you can skip the multi-dex using SDK 21. But this is the small stuff. In my experience, simplification comes from a few very, very, very specific topics. First, modules, having more than one Gradle module, so decoupling your code base and enabling people to work on different stuff at the same time without stepping on each other's toes. Giving actually a second thought to things like RxJava and annotation processing. Well, annotation processing is all the rage nowadays. I mean, 5 years ago, if you had some duplicate code, you will extract a method. Today, you write an annotation processor, because apparently it's cool, but it's also super, super, super slow when it comes to incremental build. There is a lot of work to do to make it incremental build efficient, I will say. And that keeps the code base a bit complicated and a bit slow. From the Rx point of view, well, RxJava is a pain point nowadays. And it's part of the simplification process that I went through with my project this year. But let's make the build faster as first thing and improve the modularization. So we decided, but we need to do we need to understand, assess what's the status of our code base. Splitting the code base in modules is definitely a journey. Depending on where you start from, it can be painful, very painful, and unbearable painful. So I would say if you are starting from God activities, well, good luck with that. Nowadays, I'm pretty confident that a lot of you have at least some sort of pattern architecture on the presentation layer, MVP, MVVM, or MVI, MV whatever. That's a decent starting point. If you have something like clean architecture, that's a good starting point. But if you are, so if Uncle Bob is very proud of you, you probably will end up with 3 modules: data layer and a data domain and UI. And that's it. You basically plateau after 3 modules. Antonio Leiva, a couple of days ago, published a blog post. He was also suggesting a couple of more modules. Like he talks about framework modules where you put everything that relates to Android, and an external module with stuff like libraries that you don't actually manage or you own, so you segregate. But eventually you will still have like 5 modules. So if it works for you, super. But eventually the build speed will plateau, because you start putting a lot of stuff in those 5 modules, and probably in 6 months you will be where you are today, and you need to improve on that. My approach, a successful approach that I tried, it was splitting the app in feature modules and then apply clean architecture if you need, or if you want to make Uncle Bob proud of you. So my general approach is having an overview of what's in your app. And this is a very, very general purpose app. Probably most of you can apply the same overview to your product. You have a few features, and you have something that resembles a module as it is, like a user management module, an onboarding module, the home landing screen module, and then you have the common stuff, and you have a setting screen, so you could have a setting module. My first approach generally is going with user management, so try to come up with a solution for extracting the user management system, because it's if you were at John Sandel yesterday, John talks, he was talking about locks and keys, and the user management system is something that you can actually segregate away from your app when the user is not logged in. So it's a nice starting point most of the time, and it contains basically everything. It's basically the user management module is a full stack. You have networking, you have persistence, you have UI, you have navigation flow with UI, you also have strings localization. It's a very, very complete module. And so if you start with the navigation, with the user management, you probably will start with the networking. And the networking is one very tricky place to start, because if you're working on Android and you need to communicate with the backend, first thing you do is create a retrofit client, okay, HTTP client, you put a service there, you put one line in your nice interface, and you fetch something from the internet. And then the app grows, you get more interaction with the backend, but you gotta be fast, so we also put the second endpoint in the same retrofit interface. And 6 months later, the whole thing basically contains 200 possible endpoints call, and it's not easy to maintain. And you don't realize, you postpone it. Usually, we are gonna fix it later, but in computer science, later means never. So until you face the fact that you want to split the retrofit client, you will never touch it. Or, I mean, you only touch it incrementally, basically. But if you start moving stuff from the user management system, everything will basically collapse because retrofit will break. So a possible approach, it could be putting retrofit in every module, something that we did in one of my previous projects. So every module had its own tiny network layer, or you put the network layer in a common module, in a, you can call it core module if you want. And this is the approach that we are having nowadays. So we want to build a core module. And let's think about the core module. Well, the core module has definitely networking because every other module is using networking, persistence because probably everyone else wants to store something, utilities, and then you have the strings in the same module because you have one single point to localize your stuff. And turns out user management and core, they are super similar. So that's also when you go up in the abstraction layer, a lot of stuff looks similar. But so now we decided that we go for the core module, and it's okay. It's okay. Core modules are super useful, but they also have a very, very subtle danger in them because they are shared across every other module. So what do you do when you want to share something you don't have time to actually do it properly? Well, you drop it in the core module. In 6 months, the core module will be some gigantic monster that you don't want to maintain anymore. So be careful. But let's stick to the core module. We agree that we will be good citizen. How do we start? Well, this is it, pretty standard stuff. You move a file, you build. If it builds, you commit. Commits are free. Use them as much as you can. And then you move to the next file. If it doesn't build, you try to fix it, and then you commit, and then you move to the next file. This thing is super boring, like insanely boring. Because the build is slow, so you're waiting and waiting and waiting over some random data class that you moved in a second module, but it's a necessary evil from a technical point of view. This creates a few challenges from the product point of view because this whole journey that we are having right now has basically zero user impact. There is no user value from a product point of view. It's just a technical thing that improves the life of developers. Yes, from a company point of view, it will make the code base better so people won't quit, also nice, and people will be generally happier, also nice, but it's a hard sell, so you have to be prepared to sell this kind of stuff to your management. But this is a nice opportunity to pair with a colleague, even if it seems like there is basically no coding involved. Constantly waiting for the build will spark communication, will spark a lot of small talk about the code base. Most of them will be ranting about why this stuff is so messy, but there will be a lot of knowledge shared across the team. And it's also a nice opportunity to put down some documentation. And it's all about simplification, so you need to do it. You build a team also doing that. Now that we have an idea how to build modules, we can move to annotation processing. And annotation processing can be approached in a few ways. One big player is definitely Dagger. And in my experience, I just got rid of Dagger. Simple as that. Well, I replaced it in a couple of days with Coin. Like it or not, works. And I regret nothing. YOLO. So no more Dagger in my code base. Things like Room. I mean, you also can get rid of Room, but the thing is nice, so I will keep it. And things like Glide, everything that has its own heavy annotation processing. One of the approach that I use the most is segregating them in separate modules. So you have like just the module with Room inside. You create a nice interface around it. And if you decouple it enough, it won't build constantly for every build. So you will save a bit of build time there. And plus, you decoupled even more. So the day that you want to replace Glide with Picasso or Room with Realm, you also have easy life at that moment. And well, people argue that you can also have like the network layer in every module. You also can have the database in every module. That depends on your approach or your code base. Even in that situation, you are not building every module every time, so you still save a lot of build time. And now we get to the main topic. There was a lot of discussion this year about RxJava. I tweeted something like, it was a very innocent tweet. There was a signature from a method, and you had single of either of throwable or user profile, fetch user profile. And my comment was more like, this single line contains about 10 years of computer science, because to get a grasp on reactive programming and monads and whatever, it will take a while. A lot of people commented on the tweet, and we started a conversation about coroutines versus RxJava. It was the beginning of the year. The thread on Twitter also sparked a panel at DroidCon Berlin and a podcast that you can find online, because the topic is getting bigger and bigger. It's more like simplification versus using the right tool, like Fernando was saying yesterday, using the right tool for the right job. And everything started a few years ago. Back in the day, Eric Meyer in Microsoft created the Rx extensions for .NET. In 2013, we got a big present from Netflix with RxJava. It became very popular over time. It became the standard de facto over time. This year, we are re-evaluating it. RxJava, probably, how many of you have worked with a code base that has RxJava in it? You can wave, yell, clap. That's a lot of people, yes. And that's a lot of people for a reason, because we didn't have anything else. Well, async task, come on. Just give me a break. So async task was a thing. We needed something else. When RxJava came out, I mean, it was the best thing since slide spread. The whole thing was awesome. We could do multithreading. We had a bit of functional programming in the code base. There was a lot of power. There was like a slightly steep learning curve, and people kept telling me the learning curve is too steep, and I was like, well, I don't think it's a curve. It's like more like a wall that you climb, and once you are at the top, you got it. That's it. It's not like incrementally understanding RxJava. It's a switch. Either you get it or you need more time to get it. Because, yes, I mean, you get it at some point. But it's not always that easy, because turns out, well, multithreading is still hard. I don't know if the animation works. I love the template, by the way, so I'm trying to use the fancy stuff. Multithreading is still hard, no matter what. And when it comes with things like subscribe on, observe on, what's a scheduler, are we using threads, what's the threads, what's the main, observe on is giving me back main thread, well, that's not that intuitive. So it takes time, and if you are in a hurry because you want to use the thing, but you don't have time to understand it at the full, it's get trickier, and you have a lot of threading, jumping, and you have a hard time when you want to debug things, because one of the thing that you learn very, very, very soon when you use RxJava is that most of the time the breakpoints are laughing at you. like literally why this thing is not stopping, why this thing is still, the progress bar is still going, what, and then you have crashes in production and you go there and you check the stack trace and Crashlytics is laughing at you because you have 2 million lines of nonsense and there is no reference to your code. So it's not rainbows and ponies all the time. Oh, this is cool. So something that is also super cool is RxJava comes with like 1 million operators, like literally 1 million operators. There is an operator for everywhere. And then you started actually go crazy with this stuff because for the first time on Android you have something like filter. You can filter a collection. But you don't have a list, so you can wrap everything in an observable, and then you have a nice way to filter a list that actually it wasn't an observable in the first place, but well, I have the operator, let's use it. Over time, you get very bold, and they are not enough anymore. Like 2 million operators, they are definitely not enough anymore. So you want one more operator, a very specific operator that you build for your very, very specific use case that is completely undocumented, so everyone that comes and joins the company has to ask to you how the operator is gonna work, and it's supposed to work, why it's not working, and if they are lucky enough, you are still in the company, otherwise, well, still good luck. Over time, the whole discussion around RxJava became very, 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 we need to put it everywhere. So Retrofit came and they added support for RxJava, and so you can chain retrofit responses, and people start thinking about, okay, but retrofit is not giving me back a sequence. Okay, there is no sequence. I call the backend is gonna give me back one element all the time. Well, let's create a new type, single, boom. I have something that I want to run on another thread. It's actually not even giving me back anything, like just none. I just want to know when it ends. Well, let's create completable. And then you can put everything together, you can flat map, you can combine lattice, and then you realize, okay, this is actually an observable, but this is a single, how do I combine them? Well, and you have two observable, boom, cool, and then you have a single here, and you want to combine it with this other thing that actually is returning you a completable. How do we do it? Well, you have two single, and then you have this incredible back and forth from types, and then you have RxJava 2, so you get other types, you have flowable, you have back pressure, blah, blah, blah. And I'm waiting actually for the whateverable that will solve every problem, because you just have everything in the same chain, everything is everything else. So it could probably improve, simplify things. But the worst of having RxJava in your code base is that the law of the hammer becomes like a day-by-day reality. So you have a hammer, everything looks like a nail, okay? So you want to solve everything with RxJava. And even worse, you are actually looking for problems that can be solved with RxJava. You are actually looking for nails. And this actually puts you in a very, very, very awkward position, because your whole mind become different from the common sense mind, where you actually are solving problems in a normal way, instead of, well, you are in love with the tool. So you are actually designing the system to be RxJava centric. And it's not always right, and it's not always maintainable. Because a lot of people, unfortunately, are working in very stressful environments. So there is time constraints, they want to use the tool, they love the multi-threading part of the tool. So you see a lot of single, I'm gonna fetch a token, okay? What if the token is expired? Oh yeah, this thing is gonna be in the on error, and then I put another single in the on error to fetch the new token. And well, what if the token is okay? Well, we will be in the on success. At that point, I put another single in the on success to fetch the user profile. What if I don't have internet? And you have this gigantic nested subscribe, single subscribe observable because nobody got time for flat map. So you actually see this stuff, and this becomes very, very, very hard to work with, to debug, and to think about your code base. You need simplification. And on this side, RxJava, it's very, very, very hard to simplify when it's abused. So we need to kill RxJava. Not really, because RxJava is a tool. It's a tool like any other library that we use. There are plenty of use cases where you can actually effectively use RxJava. If you have reactive UI, UI is the perfect example of a reactive scenario. Basically, you don't know when the user is going to click, when they are going to drag and drop or scroll. So you can only react to their input, and that's perfect for RxJava. If you have a UI that is maintained with like a state machine, like Redux kind of thing, or MVI, RxJava is perfect for that because you have a constant flow of events or states of your UI. That's RxJava, all the things. If you have something based on reactive database, Room has support to Flowable. If your architecture is database persistence driven, that's perfect. I mean, RxJava is the perfect tool. Even if you have something simple like Rx shared preferences, it depends how you create your architecture, or it depends also from the domain that you work in. I work with location a lot. Location is basically you are not in control of the data. You have Android pushing locations to you, and you can only react to the data that comes in. You don't own the data. You don't control the data. Every external source of data, like a WebSocket or push notification, they are perfectly the perfect scenario for RxJava. Or IoT. How many of you have interested in IoT? Perfect. Imagine if you have experience with sensors. Imagine you have a very cheap temperature sensor, and you can query it every 2 seconds. If you query it too quickly or too much, it will die. That's a pretty standard scenario. What you can do, you wrap the sensor with Rx wrapper interval to query the sensor every 3 seconds. You share the observable, and that's it. You got a very cheap temperature sensor, and now you have a system, a reactive system that can scale as you need to any number of consumer you wish. So there are scenarios where RxJava is the proper tool, but not everything needs RxJava. And for every other asynchronous concurrent scenario, nowadays I'm using coroutines. So yesterday we had a couple of talks introducing coroutines. Coroutines are the gift that JetBrains gave to the JVM world. And they are based on an old concept, and they are implemented with a lot of magic under the hood. But the thing is, they are super solid. They are gonna be also out of experimental, or they are already out of experimental. So I've been using them for months, so I really don't care about the official position. They are nice to use. Actually, they end up giving you a very familiar syntax. The code is pretty much like an imperative block, so new people can be on board in a matter of hours. And the only thing that changed in the language was a new keyword. They just put a suspend keyword to actually mark functions that can be suspended. A suspended function needs a coroutine context, and basically the coroutine context is the only block of code that can run a coroutine. Wow, a suspendable function. Come on, let's put some code here. So you have coroutine context builders. The first one, basically the class one is launch. We have a very, very easy, simple example of suspendable function. The whole thing is just returning true after 2 seconds. How do we use it? We wrap it with a launch method. And all these functions are basically functions built with the language itself. So they don't come with coroutines. Most of them, they are like either extension functions or just plain function with lambda parameters, so pretty smooth to use. And as you can see, the first launch and the second launch, they differ they got a parameter. In the first example, the parameter is default. Common pool is so-called dispatchers, gives you an idea where the things are gonna run. In the third example, I'm using the Android one, so you can actually get the result on the main thread, and you can interact with the view. The text view.text is super basic example. I will advise you over time to structure your code in a different way, having a presentation layer with decoupled. Just don't put everything in the activity like, well, my example suggests. But the thing is, okay, I get it, but how do I use it with RxJava? So we can try. You just stuck the single there. It's not gonna work, unfortunately, but people like JetBrains, they don't sleep. Yes, this is the official company statement. They don't sleep. And over time, they build adapters for a lot of reactive libraries. So you just put a dependency in your Gradle file, and you basically end up with this. You just await on the single, and you're good to go. So you don't need to rewrite your RxJava code base from scratch, because the idea is migrating in an incremental way, because we want to move from like an insane amount of flat map and concat map and whatever map to something that is more readable from a user point of view, well, also from a colleague point of view. And you can adapt your code base very quickly. You can decide today that you are gonna write the new stuff with coroutines, but still using the old stuff that you have with written with Rx. With this, basically, it's an extension function around reactive types. Single have an await. So if you have like a single that retrofit call that retrieves a token, you just await on it. No big deal. And you can do the same stuff. You can just, probably you will have a lot of await in your code, but that's part of the game. But you don't need to rewrite everything from scratch. And the beauty of it is that if you start working with coroutines, you end up, but you are still migrating your code base away from RxJava, or you are simplifying your code base, you end up also on the opposite scenario. So you end up with an old file that probably is not even, well, let's say it's Kotlin, but it's still full of RxJava stuff, and you want to use something that is already written in with coroutines. So that becomes tricky because you have to wrap everything, but once again, they don't sleep. So they also got you covered on the other scenario. So this is, it's a very common scenario when you start writing coroutines, all the things, because old stuff that it's in RxJava, you still need to interact with coroutines. And the fascinating part that is with these adapters that they built, you have 100% interoperability with RxJava and coroutine on both ways. So you can create a single from a coroutine with this coroutine builder, voila, with a coroutine builder, and at the same time you can await on Rx type using the extension function that they build on the type. So it's something that you can do incrementally. It's something that can be done pair programming together with the rest of the team. It won't affect negatively the mood, because it won't be like a massive rewrite. Project manager are kind of okay with this kind of stuff because they don't know anything about. So it can be a nice team building experience. And you can start today to simplify your code base, simplify your day-by-day life, and being a happier developer, I will say. Thank you. We definitely have a few minutes for questions. If you, wow, okay, that was quick, perfect. I was up, well, whatever. Just wait, please. Everything okay? The mic is not working. Who's gonna yell a question at me? I can repeat the question if you yell it, so we can share the pain. Do I have experience using, he was quicker, come on, man. I have so do I have experience using live data? In combination with Rx, not really, because they are kind of, they overlap in a meaning of streaming the data. So we usually, if we use view models and live data, Rx is basically in the domain logic or the business logic. I use it together, live data in the UI and Rx in the domain, yes. Thank you for the question.
Hi, I have the mic now.
Perfect.
Thanks for your presentation. I think we all really enjoyed it. I just have one question. You haven't mentioned anything about error handling with coroutines. Do you have to put everything in try and catch blocks, or is there some mechanism we can use?
Thank you for the question. So error handling, the basic approach will be try and catch, ugly. So it's my personal opinion. On the day-by-day, we are trying to use, well, they are coming out with the result type. That is also nice, something that it's used. You have a type that wraps your result and you get an on success, on failure. That's also nice. In my experience, either also work if you have experience with Arrow KT, the library. They have monads for everything, and either it's a type, so you basically have you can have like a pair. On the left you have the throwable, the error, and on the right you have the right value. This computer science is brilliant. So either is also an approach. Depends how. Depends on your team. Basically, my experience, that's a very, very, very much a team decision, how you want to handle error management. On Rx, a lot of people just use on error and they live a cowboy-style life. I prefer to treat errors as first-class citizens, so I will go for like either or SILT class that model the result, and they can model the error as well. Thank you. Any other question? There was some person. Oh, did you get a mic?
Yeah.
Perfect.
Thank you for the presentation. Rx has some libraries that give you cool coupling with Android lifecycle, like Rx lifecycle or autodispose. Does coroutines have anything for that?
Thank you for the question. So coroutines, for instance, the launch the launch function that I show actually gives you back a job object. We saw the job object in Fernando's presentation yesterday. And the job object is basically like a disposable for RxJava. You can actually cancel it. The idea that you manage it, the life cycle as you wish. You also have a caveat that if you build your own coroutines, they need to be cooperative when it comes to disposability. So you have to be careful how you dispose the task in your coroutine. But yes, I don't have the day-by-day experience, but I'm pretty sure that they are working on some sort of lifecycle observer integration on Android. But usually I use the coroutines on like lower layers, so I dispose of them manually because there is nothing to work with Android. They are pretty separated. Any other question? No? Any help from the stairs? I can't see hands and phones or clapping. Oh, I have another question here.
Hi. I know that in the coroutine library there is a concept of channels. Have you used them, and what's your opinion about it?
Thank you for the question. So channels are like a coroutine implementation of subjects-ish, where we are missing a lot of operators. Basically, it's an entity that you can send objects, okay? They can be used. Yesterday there was a very effective, very interesting talk about actor model for iOS. On Kotlin, we have a ready-to-go implementation of that model using channels. So I usually don't use them because coroutines are more for the asynchronous stuff. So I have usually a different kind of logic. But channels, yes, definitely. There was a blog post by Fabio a couple of days ago, and he was talking about doing the unidirectional data flow in the UI using channels, the broadcast channel. So yes, it's definitely a useful tool, but again, you need the right use case for it. So no strong opinion against it, no heavy experience with them, but they are definitely there and they are definitely useful. Thank you. Anyone else? Good to go? Thank you again and enjoy the rest of the conference.